Today I'm very excited to introduce Gopal Hegde.
I think if you go back in time, AI is actually not, it's very recent. Okay, it's actually very recent, right? Do any of you know when the first AI network ran on a machine?
I want to introduce you today. I'm very excited to introduce Gopal Hegde. Gopal Hegde is a close friend of mine, and we went to the same school actually, but different years. He's much younger, and he got an undergrad in computer science from NITK. Then he did IISc computer science. Then he went to University of Massachusetts Amherst for another computer engineering. So we met in Silicon Valley. He has been with a lot of the big companies in Silicon Valley, as you guys know, Intel, Cisco, Marvell, and a lot of the focus on system on a chip, especially in the last 10 years. And his latest startup is SiMa.ai. It's the heart is the AI, right? AI at the edge. It's called at the edge. Okay, so we want to understand what that is and how we can use at DriveU, how we can utilize that. They have both a hardware and software product. For example, a chat GPT is on a chip. So you can actually, the large language model will be on a chip. And so you can actually make queries and get on, because once you have the data, you can actually, you don't even have to go to the internet. You can get your own local. That's pretty cool actually, what they have done. It's a in order to make it work, it is low power. Okay, it's a low power system. And so today he's, sorry, I forgot, he's the Senior VP of Engineering for SiMa. I'll give you. SiMa, isko ek de do na. Sorry. She got her bones. She'll go chew on it. So he's a Senior VP at SiMa.ai based in San Jose, and they have a big facility here in Bangalore. They're a tech team here. So welcome.
Thank you, Ram.
Yeah, and
very nice to be here.
And I forgot to say he is an investor in DriveU multiple times.
So thank you for making.
So give us an for us, we don't know much about AI and all the stuff you're doing in hot Silicon Valley. Give us how it's growing. And by the way, this is one of the leading companies. Was recognized one of the top 10 AI companies a few years ago. I mean, very big name, SiMa. And I know his co-founder also from Xilinx, great guys. So,
thank you, Ram. Very kind. And so again, I think if you go back in time, AI is actually not. It's very recent. Okay, it's actually very recent, right? Do any of you know when the first AI network ran on a machine? Any guesses? What do you think? What do you think? 2012. Okay, so 2012 was the first time there was a feature on Jensen Huang and NVIDIA in Wall Street Journal like a year and a half ago. I didn't know that either. Okay, I also used to think AI, and when I went to school, when I went to Indian Institute of Science, I don't know how many of you learned Lisp programming, and there were all these Lisp. Okay, was a programming language. The challenge with AI was that there was no compute infrastructure capable of running these models, okay, in those days, right? So in 2012, Professor Hinton, he won the equivalent of Nobel Prize in Computer Science very recently, George Hinton, a very famous professor at University of Toronto. He and his team took a NVIDIA GPU and they ran the first ML model. They called it AlexNet, okay, and in last 13 years, it has changed the world in a huge way, right? And NVIDIA has gone from being a company. When I was in Intel, we used to think NVIDIA will kill them anytime. We'll just integrate graphics and NVIDIA will cease to exist, okay? So they have gone from a no-name company to one of the most valuable companies in the world, okay? Actually, the most valuable company
in the world.
Okay, in the world, right? And they have grown from a revenue of 2-3 billion to over 120 billion now, right? So the transformation has been very rapid, and basically the way this whole thing happened is that they ran AlexNet. AlexNet is one of the early networks that does computer vision. Okay, so it recognizes objects and recognizes people and recognizes things. So computer vision has been around for a long time, right? So the AI started with computer vision, right? Computer vision has been around for a long time, right? So if you look at robots that are being deployed, so the robot that makes coffee for you, that makes pizza for you, or the robots that are in the industrial automation, the so-called mobile robots that actually follow a black line. They bring tires from one place to assembly line. They bring seats to another place. So these are all what they call fixed function robots, and they have cameras, and they use cameras to actually detect people. So if you go in front of them, actually it stops. Okay, so it doesn't run over you. It detects people, but it works in a very fixed environment. Okay, so like fixed lighting, fixed environmental conditions, etc. So when you actually put these devices out in real world, okay, so it could be raining, it could be cloudy, it could be dark, it stops working. Okay, so with AI, what you do is you actually make them smart. Okay, these computer vision systems. How you make them smart? You bring all kinds of images and you train the model. Okay, so you teach the AI model what is actually good and what is not good. Okay, typically you teach what is good. Okay, so then everything which is not good is bad, right? So then you iterate. You say, okay, you know what, this is not good enough. Okay, so you iterate. Okay, so a model, AI model, is as good as how it is trained, and it is as good as the data you train it with. Okay, so that's how it started, computer vision, right? And it's taken a long time for not a huge amount of time, because there's tremendous value in customers actually deploying AI. Okay, so we have a number of customers. I'll give you some examples, right? So one of the customers that we are working with is a company called Baxter International. Okay, so for those of you who don't know, Baxter International is #1 IV bag manufacturer in the world. They are one of the largest medical companies. They are like a Fortune 100 company, 24 billion in revenue. They have 70 plants. Okay, so in just one plant in North Carolina, they make 1.5 million IV bags a day. Okay, so they actually, the way they were doing this is that they look at an IV bag, okay, and they say, is there any contaminant in the IV bag? Because if there is a contaminant in the IV bag, like a piece of plastic, it goes into your body, really bad for you. Right. Okay, and it goes straight into your bloodstream. Okay, so they were actually doing manual inspection on these bags. Passes through, they do manual inspection, and they get, because they have humans, they are a lot more, conservative. Over 40% of the bags would get rejected. Okay, so their false positive rate was 40%. They deployed our technology. We improved the we reduced the false positive to 7%. Okay, so now think 1.5 million IV bags a day in one plant, multiply by 33% improvement. What is that number translate to? Okay, so this is possible because of AI. They actually train the model with what is good, what is bad. So that's how we started with them, and now they're deploying us in lots of different applications, right? I'll give you another example. Those assembly lines on which you have boxes, okay, like FedEx, they have boxes. Baxter has what they call a print station, okay? And this is the difference. I'm just trying to draw a contrast between AI-enabled systems and non-AI, okay? So when you have a non-AI-enabled system, okay, you have a, like something like this, right? It has printed material, right? So goes through assembly line, it reads your printed material, and it knows that, okay, this particular bag needs to go to hospital A or whatever, right? So it needs to be picked up by the robot, put into this pile, okay? So that, now if this phone becomes thicker, doesn't know what to do, okay? If the font changes on this phone, it doesn't know what to do. So every time something changes, you have to adjust the camera, you have to adjust the system. It's very manual, very expensive. And all the barcode readers, everything are operating like this, right? So think about a FedEx or a DHL shipping line, okay? There's a small box, there's a big box, okay? You don't have any control over what box size. If you don't use AI, how do you automatically scan these things? So what do? They use humans. Barcode, okay? They put barcode, they read, and humans make mistakes, Okay, one of our customers, large luxury car manufacturer in Germany. Okay, so these guys have final inspection where they actually check the car after the car is built. The cars are $50,000-$60,000, right? So the humans make mistakes. 2% of the cars go all the way to the end customer. They find, tears on the seats, carpet smudged, wrong, wheel fixed, sometimes missing screws. Car comes right back, reputation damage, costs a lot of money to fix it, etc. Right? With AI, you can actually detect these problems in real time and solve these problems, okay? Because it's much more accurate compared to humans, right? So that's basically how the whole thing started, okay? And and then the way the AI was deployed, okay? Because it's not easy to deploy AI, okay? So you need to collect the data, you need to train the models, and it's actually interesting. Some of these large companies, we work with companies in India, we work with companies abroad. Okay, so we went to Tata Motors, I think Vaibhav went there. They say they have no data, right? I mean, they don't know how to collect the data. It's not about just take some pictures and, okay, here, you have to take pictures under different lighting conditions. You have to take pictures under different environmental conditions. They don't know how to do this, right? So deploying AI for these use cases is very hard, okay? So where AI got traction was in the cloud. Okay, so the Amazons, the Googles, the Microsofts, they actually have thousands of engineers and they develop AI, okay, algorithms. They know how to use complex chips like NVIDIA. NVIDIA chips are not easy to use. Correct. They have CUDA, they have TensorRT, and they have their own programming language. They're not easy. Parallelizing things is not easy, right? So you need to know how to do the work. So easy for Amazon to do it, and they then offer it as a service. So a customer can actually use, Amazon, they can use Google and things like that, right? So that's where it took off. And it took a really long time for it to actually start proliferating. And the early AI applications all ran on Intel CPUs. Okay, so it's actually very interesting. If you go back there were two parts to AI. There is something called training. Okay, training requires a lot of compute. Training is about feeding lots of images, lots of data, telling the model what is good, what is not good, okay? And you may have to train it with 50,000, images, 100,000 images. Then you need to validate it with a certain data set. So that whole process is very compute intensive, okay? So NVIDIA GPUs were actually used for that, right? And to run inference, it ran on an Intel CPU. In fact, in 2019, 85% of inference workloads ran on x86.
I didn't know that.
Yeah, I didn't know that either.
Yeah.
Intel didn't know that either.
Yeah.
Okay.
That's funny.
So they never did anything about it. So then as the applications became more and more complex, okay, the Intel CPUs could not keep up. So they moved to NVIDIA, okay, right. And especially in the cloud. And when it ran in the cloud, it's offered as a service. You don't need to know anything about it. Right. Okay, you just use the service. Okay, that's how it really took off, right? So fast forward, I'm sure everybody in the world has heard of ChatGPT, right? Mm-hmm. So ChatGPT came out of nowhere, okay, in 2023, but it was being worked for a long time, right? The ChatGPT, which actually caught everybody's attention, was fourth version of ChatGPT, ChatGPT right. 4, okay? The fifth version came very recently. There was 1, 2, 3 before that, and they were not as good, they were not as accurate. So the computer applications, the vision applications use something called convolution neural networks, okay? The primary operation in convolution neural networks is a convolution operation, okay? It's a mathematical operation. AI has very strong foundation in mathematics, by the way, okay? And then the ChatGPT and those use what is called transformers. Okay? Transformers were developed by Google, okay, and research, this tremendous amount of research that Google did, and all the pioneering papers were all published by Google, okay. OpenAI took advantage of that, and they basically brought out ChatGPT, and ChatGPT really took off in a big way, because it's a very easy way for people to communicate with the AI platform, right? It's your grandma can use AI now, right? Okay, so it caught world's attention, and there is tremendous growth in the infrastructure. Over $600 billion have been invested in the AI infrastructure now. A lot of companies are actually taking advantage of that. And even in automotive, for example, right, like, ChatGPT is now available, right? And car, you have a vehicle, and when you're driving the vehicle, you can talk to the car, it can actually talk back to you, it can actually identify the buildings, it can, you can say, take me to the nearest Domino's Pizza, it figures out how to go there, all using ChatGPT, right? And it makes the overall application using internet, using AI very easy, right? That's really what has happened. And that's how the industry has grown, right? And we have migrated from CNN. CNNs are still very widely used to, Gen AI. And, it has happened over last 13 years, to be really honest. And the ChatGPT is just 2 years old, 2.5 years old.
Right. So coming back to what SiMa does, right? Different.
Right.
You are more focused on industrial automation and so on, right? Market.
Yeah.
Because, in our case, we are sort of mostly software.
Correct.
We actually our team uses ChatGPT and other things. So my interest was primarily, you have a ChatGPT on a chip.
Correct.
So I don't have to go on the internet.
Correct.
I have it right here locally.
Right.
How has any customer used this?
Yeah. So this is a good question. Okay.
Right.
So absolutely.
Yeah.
So our first generation was, so to answer your first part of your question, what is the difference between us and NVIDIA, right? So, I mean, one of the lessons you learn, and Ram is a master, he's been in many startups, right, is that when you're a startup, you go after a market. You need to go after a market where you don't have a very strong incumbent. Okay.
Correct.
It's very hard to compete with an Intel or a Broadcom or NVIDIA, right? So, as they used to say in earlier days, nobody gets fired for buying IBM, okay? So they just buy IBM, right? And, even if you have a better machine, nobody really cares, right? So you don't want a market where there is such a strong incumbency. Many of the AI startups that came out focused on the cloud. There were many that said, hey, because cloud is where the volume was, and there were big customers, 6, 7 big customers.
Right.
You win Microsoft, you all of a sudden have like $100 million customer, right? The others focused on phones and things like that, right? The challenge is that these companies have more money than what they know what to do with.
Right.
They can build their own product. So Apple built their own chip. Okay, Samsung built their own AI chip. The startups who actually built chips for them were deployed in test products and thrown out. Okay, so those startups completely folded. There are a lot of startups which said, I'll build better hardware than NVIDIA. This business is not about hardware. Okay, and you know better than anybody. Hardware is just an enabler, right? Software is where the value is. And the big NVIDIA is not a hardware company. Okay, they are a software company.
Right.
And they have been successful because they have built a very compelling software. In fact, I don't know whether you know this or not. For 7 years, AMD has better graphics hardware than NVIDIA.
Right.
They were generation ahead of NVIDIA. Okay, they had better power, they had better processing capabilities, they had better GPU capabilities, but their chips have no software.
Right.
And if you look at NVIDIA, they have over 300 partners who develop for NVIDIA platform. AMD has 32.
Right.
Okay, so this is where the value is. So when you have all these giants who are competing in the cloud space, we basically said that's not our game. Okay, I have tried to compete with these big guys, even in Marvell, in the cloud, and we were somewhat successful enough to sell the company, okay, for a good amount, but not successful as in, we didn't get to $1 billion revenue.
Right.
Okay, so basically, cloud is a very hard,
market
nut to crack. So we said we're going to go after an underserved market. Underserved market is embedded. Underserved market is edge. We defined edge as something that touches you, the physical AI. Okay, NVIDIA is now talking about physical AI. We were very early to physical AI.
Right.
Now, it's a very challenging thing because when you go to a market like this and you are early in the market, the companies are all interested. Okay, we have no lack of interest in people actually talking to us. But then they don't know how to build an AI system.
Right.
So a lot of the reinvention we had to do was on business models, as I was describing to you, right?
Yeah.
How do we go to market?
Right.
Okay. How do we get customers to adopt our technology? And what has really worked for us is close partnership with customers on creating a solution that then they can deploy.
Right.
Okay. So we built an application team, we built an SDK, we built a toolkit which our application team uses to create solutions for customers. Customers come with problem statement for us. And it's amazing, right, that these multi-billion dollar, large, tens of thousands of people companies, how little technology they use, especially when it comes to AI. Okay, so they do a lot of things manually. They have a lot of issues, and the value proposition for us is we can actually simplify a lot of these things, but it requires us to work with them to demonstrate that how our solution can be used, which is sort of what we have done. And to your second part to your question about using ChatGPT in the, so here is the thing, right? So when you are driving, okay, you could be going through a area where there's no cell connection.
Tunnel.
Number one. Yeah. Not even, right? Most parts of Bangalore, cell connection is very poor, okay? I get no signal, right? I mean, by the way, it's not unique in Bangalore. It's everywhere.
I know.
Okay? A lot of black spot,
dark spots.
Dark spots. So no cell connectivity. So that's one problem. Second one is that your response is slow.
Latency,
right? Humans are used to a certain speaking cadence, right? If you send, if you ask a question, and 30 seconds later is still waiting, okay, it's very annoying, okay? You cannot have a conversation like that, right? That's the second problem. Third problem is a lot of the conversation you want to have with your car, you want to keep it private. You don't want the entire cloud to have all that information.
Correct.
Privacy is a very big deal, especially in Europe, okay? So, and the fourth problem, which I don't think people have appreciated, is here is the math for you. ChatGPT charges you $200.
Yeah.
Okay. They pay Google Cloud, okay, about $2,000.
Really?
Yeah.
Wow.
Okay. And then, of course, you can negotiate. Maybe it is 1,000 for some other cloud.
Right.
Then Google Cloud pays 40,000 to NVIDIA. Okay. So the economics is totally inverted. Okay. So they are losing money every year. The venture capitalists are funding these guys, billions of dollars. But even then, when they give it to a commercial user, okay, each token processing cost, okay, think of a sentence, each word is a token, okay. That's not really a direct approximation, but something close enough. So think of each word in a sentence you speak is one token. Each token costs 6 cents to process in the cloud. Okay, so who's paying for this?
Right.
Okay, now if you are an end user, I mean, ChatGPT pays, investors of ChatGPT pay.
Correct.
But if you are Volkswagen, okay, their customer is paying, right? So cost money, right? So if you could spend $200, $300, $400, $1,000, okay, depending on how much. So okay, so these problems are real. So these people are saying, I want to address that. How do I address that? And instead of paying somebody for all those, I want to capture all that revenue. So these people are saying, okay, so we came to them with a solution where we can actually run these Gen AI, okay, on our chip. Okay, so this is our second generation chip, 6 nanometer TSMC. I'll pass it along.
Yeah.
Go ahead. So you can see, right? And this chip consumes less than 15 watts of power. Okay. We ran DeepSeek. You guys are familiar with DeepSeek when, right? Everybody heard about that?
Yeah.
We ran it 3.6 watts of power.
Wow.
Okay. We ran Llama 7 billion, which is an open source model from Meta. Okay, Meta. It's about 5 watts of power. Okay. So it's very power efficient running these large language models. And because it is local, we process all the tokens, okay, live, and we can actually get very good so-called conversational AI. Okay. So that is really what we were after.
Right.
To talk about the adoption, what happened is that we were pitching this to multiple companies. So one of the European automakers, okay, so these guys are very slow, but now they are looking at China, and China guys are eating
way
their
ahead.
lunch.
Yeah.
Okay, they're way ahead. Right? These guys are scared.
Right.
Okay, they say, how do I sell my car? I mean, you've seen the stats. Porsche revenue is down 30%.
Right.
Okay, it's a huge number, right, for them. Mercedes is suffering. Their pre-tax is 5% now. Okay, typically it used to be 15-20%.
Right.
So they're all hurting. They're saying, how do I differentiate my product? How do I make my car wow? Okay.
Right.
So we showed a demo to many of these people. So we showed a demo where we said, we took one of those boxes. Okay, November last year, I took one of these boxes and I put it in the room, 30 people in the room, and I said, okay, you can ask any question you want. How many people are in the room? It said 30. Took a picture and it said 30 people. How many men? How many women? Okay, and they showed a logo, okay, of and they said, what car is this? Okay, it picked up ML and it said the ML is a Mercedes M class. That blew them away. Okay, so they said, oh, this is cool. We should do something.
So the one thing I always worry about, with all the Gen AI, all the craziness going on, how much power we are spending in the data centers.
Correct.
I mean, this is like 15 watt. I mean, it's amazing. And then you're saying DeepSeek is 4 watts or something, 3.6 watt. I mean, can you sell based on, because can our environment sustain this kind of, the burning the environment with so much power?
No, so here is the problem, right? When you go to a cloud, okay, we have you want the challenge products like us have, and by the way, not just us, a lot of startups have, is that cloud has to be general purpose.
Right.
Okay, they have to run anything.
Right.
Okay, so because you as a customer, you don't, you throw whatever, right?
Right.
So when you have a very general purpose workload, a very general purpose platform actually is the only solution. Okay, a general purpose platform is very expensive, power inefficient.
Right.
It does everything, but it does nothing efficiently.
Right.
Okay, it's like x86. It runs any code, but it runs anything and everything, but it doesn't do a good job.
Right.
So why we are getting low power here? Okay, why is it low power? Right. What we did is that if you think about an NVIDIA solution is GPU based.
Correct.
Okay, they use this to basically, back in the day, it was a graphics card. Okay, then they basically used it for Bitcoin mining. Okay, now they're using it for, LLMs, Gen AI, whatever, right? So it can do anything. Okay, because it's a general purpose GPU. It's hard to program relative to an Intel CPU. Okay, but it is, and the way they get it is they put lots of cores, lots of hardware.
Right.
Okay, so if you look at some of the NVIDIA products, they're talking about, they start at 2,000 GPU cores. Okay, they call them CUDA cores, and it goes up to 64,000 GPU cores.
Right.
Okay, general purpose, very power inefficient, very big. Okay, so we took all the other stuff out. We only process ML. What is ML, right? ML is mathematical function. It has convolutions. It has matrix operations. It has, transformers is basically matrix operations.
Right.
Okay, that's the only thing we support.
Right.
And that is what makes our chip very power efficient. And every ML operation we accelerate in hardware. Okay, but then talking about the cloud, we can't be general purpose because we can't run anything and everything.
Correct.
Okay, so if somebody runs a random, so we cannot be deployed in Azure or it was a conscious choice.
Right.
Okay, we cannot go to Azure, we cannot go to Google, but for embedded applications, we are the best. And if you are, for example, if DriveU were to build a small infrastructure, where you say, I know what workload I'm going to run, and I'm going to run these ML workloads, you can basically put a bunch of these and you run your workload, you can run it at scale.
Right.
Okay.
So in our case, no, we have a pool of drivers and a pool of car owners.
Correct.
Okay. If we can map the behavior of drivers and behavior of car owners, then we can map it together, get the most optimal thing.
Correct.
That's what I'm more interested in seeing.
So to answer your question, right? So I asked my, my architecture guy, hey, I'm going to meet DriveU. Tell me what use cases. So we came up with 4 or 5 use cases. Okay. One is just for AI in general, right? For example, a simple one is driver monitoring. Okay. So right now, I'm sure the way you monitor driver is you get feedback from the customer, right? About the driver, etc. Right? You can do real-time monitoring of how the driver is driving. Okay. Did the driver get distracted? How many times did he brake? Okay, how many potholes he hit? Okay, did he give a good customer experience? You can collect all that data, okay, and you can analyze all that data. And basically now you can create your own rating for the driver, right? You can take customer preferences, customer data, and based on the customer preferences, customer data, you can match it with the driver information you have and figure out who is the best driver for this customer. Okay, so let's say you get a new customer. Okay, you can classify. You can use AI. So there are lots of different ways you can use AI. Okay, and that way you can actually improve your customer experience, improve your driver experience. Okay, and improve overall.
Make it more efficient.
Make it much more efficient. right? You can use AI to create new pricing models.
Right.
Okay, like the congestion pricing models, they're all using AI algorithms, right? They predict. Okay, they are not like, okay, they see congestion, they raise the price. No, they don't do that.
Right.
They predict, okay, that the congestion is going to be here.
Happen, right.
Because, congestion is here,
Right.
that means the congestion will be over there too.
Right.
Right? This is how they actually figure out pricing models, right? A lot of it is using AI, okay, and you can actually use the same technology
Right.
to actually improve customer experience and things like that.
We are taking some baby steps in that direction.
Right.
We have some technology we are actually evaluating where the driver has a partner, he has a partner app on his phone. We analyze and say, okay, is he braking? I think Kumar is working on a project where it's, he's braking hard, he's accelerating hard, he's turning around. So we are doing all that data. So that data comes to us, and maybe we can churn it using some sort of a
Correct.
right.
Correct.
And because we'll be collecting all this data.
Right.
Any moment there are 5,000 drivers driving around.
You can't look at it manually.
Right.
Okay.
No,
So
yeah.
it doesn't, how do you
analyze
And
it?
by the way, not just that, right? You can analyze patterns. Okay. So maybe the driver had a bad day.
Right.
Okay, and he made mistakes. Okay.
Right.
But he's a really good driver.
Right.
But over a month, okay, he does that every day.
Right.
Now
Then you know
that he's
the
not
pattern.
a great driver, right?
Right.
So you can analyze all this,
Right.
right? And AI is very, very good
Right.
at detecting patterns.
Right.
Okay. It is very good at basically detecting trends, okay, up or down or whatever.
Right.
It's very, very good at that, right?
Right.
And these technologies are not super complicated to use,
Right.
And there's lot of ways this technology can be used, right? So I give you one example, right? A lot of it's very popular to use this in trucks, okay? Because let's say garbage collection trucks, okay? They go everywhere, right? They collect garbage, and they may run over people, okay? They driver may be rude, etc. So they actually use camera to collect a lot of the data. And the way they do it today is that each camera has like a NXP IMX chip, and they collect the data, okay? And then they send it to a central place, and they analyze the data there, okay? And they actually do all that, right? So works well if you have one camera. Now what is happening is that one camera is not sufficient, okay? So you may be able to monitor the driver, but what happens, when you hit a curb, okay? So you need to monitor multiple cameras, right? So when you have multiple cameras, instead of having an intelligent engine in each camera, it makes a lot more sense to actually put this right in the truck. Okay. The other thing that it allows you to do is to customize your services, right? You can say, for this fleet of trucks, I want to do this kind of behavior, right? So with localized solutions with AI, you can actually do a lot more customization, right? And you can do that on the fly. You can do that on demand, right? I mean, and you can guide the driver too. How? Okay, so let's say there is a customer he's meeting, okay, and maybe he's a new driver, right? But you have history on that customer. How does the customer, what are his preferences, okay? So what stores does he go to? Where does he go for shopping, okay? So the driver already knows. So it's as if the driver now is very knowledgeable. And
Right.
that
We have
kind of personal
customer
attentions,
behavior mapped. Yeah.
Exactly.
Right.
So it gives you a very different experience, right?
Yeah.
Lots of different ways you can actually use AI.
Right.
And, for kind of your application.
Right. Yeah. Thank you so much.
Thank you.
Yeah.
Thank you, guys.
Thanks.